Hi, this is Paul with Diode Dynamics, and today we're in the electrical laboratory here at Diode Dynamics headquarters. We're going to give you an overview of how we measure the brightness and the performance of our bulbs that we end up supplying to our customers. We design bulbs here in-house, electrically speaking, as well as physically, and the biggest important factor in doing that successfully is being able to test the total brightness output and performance characteristics. This is our integrating sphere, and this is what's used to measure the total output of any bulb, such as the H11 fog light LED bulb I have here. By simply attaching the bulb inside and lighting it up, we can shine the bulb into the entire sphere, and this is going to then be integrated. Basically, all the light beams are going to be integrated into one point in the back, which we then measure with a device called a spectroradiometer. That's going to measure effectively the total energy of the light waves and give us a total flux number, which is then measured in lumens. That's how we actually get the lumen output of our bulbs. Most sellers simply use calculated lumen numbers by taking the lumen figures of the actual individual LEDs from the manufacturer. But this isn't accurate because you can never run those LEDs at the full amount of power when you're trying to make them compact in an LED automotive bulb. You'll usually run them at half or 3/4 brightness instead, but that means that the brightness figures from other sellers is hugely inflated. To get accurate numbers, you need to be measuring in a calibrated integrating sphere such as the one we have here. Well, let's measure this bulb and see how we do. Okay, before we close the integrating sphere, we want to make sure that this bulb is fully heated up. LED bulbs are going to get hot as they run and decrease in brightness. At Diode Dynamics, we always make sure the bulbs are fully warm before testing them in order to get good results. So the lumen figures from us are after the bulb is fully heated up. Now that we've positioned it properly, we can get it closed and start measuring. Now to power the bulb in the sphere, we have just a general DC power supply here that we can set to a constant voltage. We have 13.3. At Diode Dynamics, we measure bulbs at 13.2 because that's the most realistic for most batteries. But we do lose 0.1 volt even with these heavy gauge wire as we travel into the sphere. So we've got this at 13.3. We then have it going to a digital power meter, which is very precise. You can see a very exact current readout here. And that's what we're going to be feeding into our software to determine exactly how many watts of power we're using and then how much brightness we get for every watt of power. Now on the back of the integrating sphere, we first have our power wire that's running in to power the bulb at our preset levels. Then we have our reference sensor, which is going to sense the total amount of light and set our spectroradiometer properly. To actually get the light to measure, we have a fiber optic cable which runs into the spectroradiometer. Now the way this works is that we're going to actually measure the light that's coming in and measure each individual wavelength or energy of those photons of light. Those wavelengths dictate the color of the light, and so we can integrate each individual photon and measure it and then get a correlated color temperature, which is going to tell us the exact color of the bulb, whether that's a cool white, warm white, or just a red or a blue. It'll tell us that along with the total energy, the total brightness measured in lumens. So let's take a look at the software now. Okay, we've taken a measurement of this bulb. The first big thing you'll see here is our spectrum distribution. This is actually all the individual colors of the light that's coming out of the bulb. This is a white bulb and a white LED, but all white LEDs are actually blue with a layer to convert some of the light to yellow. You combine blue and yellow together, and it ends up looking white. That's why we have a big blue peak and then a bunch of yellow light as well. This is our total distribution. Now, combining all this together and plotting it, we can get our correlated color temperature. In this case, 5892 K exactly, so about 5900 K. So that's how we want to make sure that all of the bulbs from Diode Dynamics are the same color. This is actually one of our competitors' bulbs, an H11 80-watt style bulb, which you might have seen in a previous video. We're just using an example here. By getting the total energy of all of these different colors and combining it, we can get our total flux number, which is measured in lumens. In this case, we have 163 lumens for this bulb. Now, final thing we look at is the electric parameters. We input our current and wattage, and then we take the total flux divided by watts to get our efficacy. So this bulb is making 66 lumens for every watt of power that it's using. You know, power consumption is not a huge deal for automotive use, but you can see for home use, you want to make sure LED is getting as many lumens as possible per watt of power. That makes it an efficient bulb. The final thing we look at to make sure that all the bulbs are the same color that we use is our ANSI color quadrants. So these are defined by ANSI, same society that regulates a lot of measurements in the United States, and they've defined quadrants for the different colors of LEDs. If you look on the back of a LED bulb at Home Depot, you'll see that there are ANSI 6500, ANSI 5700. They're very specific quadrants. Now this is one of our bulbs from our competitors, and you can see here's 5700K, there's the quadrant, and there's where this bulb falls. Like we said, it's actually 5900K. 6500, it's way out of range there too. There's inside the quadrant and it's out of range. So by making sure all the bulbs from Diode Dynamics fall in the same quadrant as defined by ANSI with our calibrated equipment, we can ensure that all of the bulbs are going to match and be the same color. I hope this video gives you an idea of the steps we take to measure the brightness and performance of the bulbs we supply from Diode Dynamics. We design and test each bulb to make sure that they meet the requirements of our customers and to make sure that our customers are getting what they pay for. We're not another drop shipper, we're not another importer. We design these bulbs and we put them to the test. You can read more at our research section at diodedynamics.com or contact us should you have any further questions. Thanks for watching.